All right, let's talk about something illegal. Not morally illegal, not mathematically illegal, but emotionally illegal. Today we're differentiating x factorial. First, a quick reminder. For natural numbers, factorial grows insanely fast. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120. In general, x factorial equals x times x minus 1 times x minus 2, all the way down to 1. But here's the problem. Factorial is only defined at integers. So if you ask for the derivative of x factorial, your brain should say, derivative of dots? We need something continuous. So mathematicians extended reality. Enter the gamma function. It is defined as the integral from 0 to infinity of t to the x minus 1 times e to the minus t dt. This function has a magical property. Gamma of n equals n minus 1 factorial. So we can write x factorial as gamma of x plus 1. Now we can differentiate. Instead of differentiating x factorial, we differentiate gamma of x plus 1. This gives gamma prime of x plus 1. Now here comes the spicy part. The derivative of the gamma function is related to the digamma function. It is defined as psi of x equals gamma prime of x over gamma of x. So gamma prime of x equals gamma of x times psi of x. Applying that to gamma of x plus 1, we get the final result. The derivative of x factorial is x factorial times psi of x plus 1. Notice what this means. The derivative of x factorial is proportional to itself, just like exponential functions. That explains why factorial grows so insanely fast. Now, let's test the idea at integers. There is a beautiful identity, psi of n plus 1 equals h sub n minus gamma. Here h sub n is the nth harmonic number, and gamma is the Euler-Mascheroni constant. So the slope at integer n is n factorial times h sub n minus gamma. So what did we learn? X factorial is not differentiable in its basic form. We extend it using the gamma function. Its derivative involves the digamma function. The final result is d by dx of x factorial equals x factorial times psi of x plus 1. And yes, this is undergraduate level calculus pretending to be innocent.